Now, here we will discuss colligative property. Colligative property. Colligative property होती क्या है? Colligative property होती है और it explain, it depends on the number of solute particle present in a solvent, not nature of solute. Means here colligative property depends on number of solute particles, not the nature of the solute. Now here it depends on first its classification. It is classified into, means colligative property is classified into first relative lowering vapor pressure, and then second one is elevation in boiling point, then third depression in freezing point, and fourth osmotic pressure. So all these property is depends on number of solute. So these are the colligative properties. First we will discuss relative lowering vapor pressure. Here in case of relative lowering vapor pressure, according to Raoult's law, pressure is directly proportional to mole fraction. So pressure is proportional to mole fraction, therefore pressure is equal to P naught into X, where P is a pressure and P naught is a pure vapor pressure. So suppose that here I am writing P upon P naught is equal to X. So both side, if I am subtracting by 1, both side subtracting by 1, we will get 1 minus P upon P naught is equal to 1 minus X. So here on solving this, P naught minus P upon P naught is equal to 1 minus X. So you can write here P naught is equal to mole fraction of solute, right? So here this is the relative lowering vapor pressure. Now here terms which are there, I am writing here P is said to be vapor pressure, P naught pure vapor pressure, and X is a mole fraction. So this is the relative lowering vapor pressure, right? Then we will discuss second, elevation in boiling point. Here in case of elevation in boiling point, now second, elevation in boiling point. What do you mean by elevation? Elevation means increasing. Means here when in a solute is added, its boiling point definitely increases, right? Because there is a formation of bonding between solute and solvent. so that its boiling point increases, that is said to be elevation. So this boiling point is depends on the number of solute particle, right? As solute is added, its boiling point increases. Means initially the boiling point of solvent is lower than the solution. So here we will discuss in terms of this elevation and boiling point. This depends on the temperature. So delta TB is proportional to M. M is a molality, right? So delta TB is equal to KB into M, and as we know, molality is a delta TB is equal to KB into molality, mass of solute to the molar mass of solute into mass of solvent in kg. So here we have this relation or this formula of elevation in boiling point, where delta TB change in temperature, right? Where KB is a molar elevation constant, or it is also known as ebullioscopy constant. It is also known as ebullioscopy constant. Ebullioscopy constant, that is KB. So here this is elevation in boiling point. Now it is also represented by the graphical. So as I am drawing also here, see there is an axis I am taking. See here I will draw a graph of elevation in boiling point. Here this is a pressure constant, this is vapor pressure, and here we will take temperature on x-axis, y-axis vapor pressure. As we know, solvent its boiling point is lower, and for solution increases. This is for solution, and this is a solvent. Now on just finding its temperature, this change in temperature is said to be delta TB. This is T2 and this is T1. T2 temperature is for boiling point of solution, as it is clear in a picture or graph, and T1 is a boiling point of solvent. Now the difference between T2 and T1 is delta TB. For boiling point difference is this. I am writing here delta TB is equal to T2 minus T1. So in this way it is graphically represented, elevation in boiling point. Clear? Now second one, that is depression in freezing point. Depression in freezing point. Depression means decrease होना, कम होना. So this is also depends on the solute, right? Or decreases. Depression decreases. So here same way delta TF is proportional to same molality. So delta TF, change in temperature for freezing, is equal to KF into molality. So you have same equation, delta TF is equal to KF into molality, as you know, mass of solute to the molar mass of solute into mass of solvent in kg, right? So this delta TB and this is equal to delta TF is equal to this. So this is the same way, but here only KF. What is KF? KF is molal. KF is a molal depression constant. Molar depression constant, or it is also known as cryoscopy constant. Cryoscopy constant. Cryoscopy constant, that is, or molar depression constant, right? So here also we will plot a graph and then we will see what is changes here takes place. See, I am drawing here graph represented by graph. See here, this is a one axis x, this is x axis. Here on x axis, that is temperature. On y axis again vapor pressure. So here what happened, the solute and solvent. See, again this is a graphical representation. See, this is a solvent representation and this is a solution. So according to this, see this point and this point, if we expand this and we'll draw and see the temperature is change in temperature na, because of that is freezing point. So here we will get so this temperature say T1, this is a T2, and the difference is that is delta TF. This is again solution and this is solvent. So here delta TF, again delta TF is equal to T2 minus T1. So with the help of this we will find the freezing point. Again, as its graph shows that if in a solvent solute is added, its freezing point also decreases as compared to solvent. Last colligative property, that is fourth one, osmotic pressure. Osmotic pressure is denoted by pi. Here osmotic pressure, what do you mean by osmosis? Osmosis means simply flow of solvent through SPM, semi permeable membrane, SPM, from lower concentration to higher concentration, that is osmosis. And osmotic pressure is that to stop the osmosis is known as osmotic pressure. To stop the osmosis is known as osmotic pressure, or in simple language, during osmosis a pressure exerts are known as osmotic pressure, right? So this osmotic pressure is also known as hydrostatic pressure. It is also known as osmotic pressure or hydrostatic pressure. Hydrostatic pressure means pressure exerts in aqueous medium. So here this osmotic pressure, pi is proportional to, or pi is equal to CRT. Pi is also equal to H rho g and pi is also equal to 1 upon V. Means osmotic pressure is depends on concentration as well as temperature and also volume, because as volume increases pressure decreases, as volume decreases pressure increases, that is osmotic pressure. This osmotic pressure is also known as hydrostatic pressure because such type of pressure exerts in aqueous, because in during osmosis, when solute or solvent, when solvent comes out or pass through the semi permeable membrane, definitely it pass there is a pressure it require, and also when it mix with the solution, again there is a pressure. So this pressure from the solvent to solute and solute to solvent, that is said to be osmotic pressure.